Assalamu alaikum students. So today we will do chemistry Cambridge AS and A level 9701 October November 2003 question number 3. Okay, so here is question number 3. Phosphoric acid H3PO4 is used in both inorganic and organic reactions. So okay, H3PO4 is made of the two-step process from the phosphorus. Okay, step 1, phosphorus reacts with an excess oxygen to form a white solid. All right, we all know that. Uh, then step 2, the white solid is then reacts with the water to form H2PO4. Okay, write down the two steps. Okay, I'm writing the equations, the two-step equation. Okay, so if I this before it's uh, like P4 plus oxygen plus oxygen. Uh, what the white solid? If this is white solid is P4O10. So we must balance the equation. So phosphorus is balanced, but oxygen is not. So here is 10 oxygen. So we put 5 here, 5O2. Okay. So 5O2, P4 5O2 is your okay. Now the second equation is the white solids then reacts with the water to form H3PO4. So white solid, which is the P4O10, which reacts with water. Okay, water. What it will give H3PO4. Okay, H3O4. Okay. So H3PO4 is done with part 1. So move to the part 2. Part 2 is H3PO4 is a weak bronzed chloric acid. Okay, define the weak bronzed chloric acid. So it's a proton donor and partially dissociates. Okay, uh, writing it's a proton donor and partially dissociates. Right, here we have done. Now move to the next part. Um, Part B. H3PO formed in the process. Okay, the reaction one is so here's table 3.1 shows us some relevant thermodynamic data. Okay, so find the enthalpy change of the formation. Okay, it's just asking the definition of formation. So enthalpy change, it is an enthalpy change. Uh, it is enthalpy change when 1 mole of a compound is formed from its uh, constituent element. Constituent elements in their standard states. Okay, so we have done with the part 1. Okay, now use the table figure 3.1, calculate the enthalpy change reaction 1. Okay, this is the table 3.1. So we have see that the phosphoric acid uh, gives acid PO4 and pH 3. Okay, so HF, if we write uh, delta H, delta HR is equals to um, uh, it should be when I look the table here. Okay, uh, it's pH 3. Okay, now it's positive 9. So positive 9 uh, and PO4. Okay, it's a 3. 3 multiplied by this a value minus 1. Okay, plus 3 multiplied by uh, minus 1281. um, okay, here we've done. And this is the reactant. Okay, minus the reactant, so it's 972. Yes, minus 4 multiplied minus 9, minus 4 multiplied by minus of HbO3 minus 970. Okay, minus 972. So what we will get? We will get. I'm just doing with my calculator. It's approximate plus 9 plus 3 2 minus 1281 minus 4 into minus 972. So what we will get? Mm, okay, positive. Uh, we'll get positive 54 kJ mole. So for positive 54, we have right with positive 54. Okay, so move to the next part. Explain why the reaction 1 is our disproportion reaction. Explain your reasoning with reference to relevant oxidation numbers. So this is the uh, reason what I'm saying. So uh, phosphorus in H3PO3 is both. I think I should be paused here. Wait a second. So it's phosphorus uh, in H3PO3 is both oxidized and think oxidized, yes, and reduced, yes, reduced, and the other factor, the you know, have you seen the equation? In the equation, P is oxidized. P is oxidized from positive 3 to uh, positive 5. Yes, here reaction is oxidized. Okay, so, and reduced to minus 3. Okay, and to negative 3. Okay, so this is the answer of the part 3. Now, part C is saying that 3.1 shows a reaction scheme that involves the H3PO4 in the several reactions. Okay, we have seen the reaction. All right, yes. It's an alcohols and ketone and the carboxylic acid, and this is the ester. Okay, identify a uh, which reacts with the propene in the presence of the H3PO4 in the reaction 2. This is the reaction 2. So we must identify the A. So A is must be steam or H2O. I'm writing steam here. Steam. All right. Uh, Draw the structure of the B. So you see the reaction and with the alcohol here and with KBr and H3PO4. So what we will get? Uh, it's something should be like bromine will replace this OH and Br becomes at this position. So I must draw this structure. Uh, so Br. Okay. So this is the name the type of the reaction that occurs in reaction 3. Okay, this is the reaction 3. Reaction 3 we can clearly see that it's a condensation reaction. Condensation reaction. Alright. So move to the next part. It's part 4. Reaction 3 is monitored using the infrared spectrometry. Okay, it is not possible to use the OH absorption frequency to monitor the reaction. Okay, the user table 3.2 to identify the suitable bond whose absorption frequency can be used to monitor progress through reaction 3. Okay, state the change you would see in the infrared spectrum during the reaction 3. So, okay, what is the bond in reaction 3? So, this is the reaction 3. So, we've seen that is a table. So uh, the bond is something you see. The bond is something like C double bond O. This is only it can shown by the 3.2. So 3 is C double bond O. Yes, this group is present in the reaction 3. This bond is present. Change in the what is the change in the infrared spectrum? Okay, so it changes absorption changes to frequency or wave frequency absorption changes uh, to frequency of the wave number from from uh, 670 to 740 670 to 670 from 6 1670 and from 71740 to 1710 something like 1750 1750. Yes, from this to this. Yes. Okay, we have done with this. Now move to the part D. Okay, this is the part D. Phosphoric acid also reacts with alcohol to form the organ phosphates. Okay, organ phosphates energy on the show. Okay. Okay, the complete the equation suggests the product's reaction with the methanol. Uh, so uh, the reaction what will be produced? It's a compound like produce, which is the branch CH3O close 3PO4. Yes, plus H2O H2O. But I think what the equation is okay. We must put the 3 here. So the equation is balanced. So this is the uh, product. This is the product. So now the last part of the question number the part D is a compound is a single phosphate. Okay, the mass spectrometry shows the molecular ion peak M ratio E of the 122. Okay, this peak has a relative intensity of the 12.7. The relative intensity of the plus one peak is uh, 0.84. Reduce the number of the carbon atoms uh, in the T and suggest the formula of the T. Assume the phosphorus and oxygen exist as single isotopes. Okay, so it must be a formula. It's 0.84 upon 12.7. Okay, it's just like this. 0.84 on 12.7 multiply by, we all know this formula, multiply by 100 upon 1.1. So just calculate, let's see, what will we get. It should be 0.84 upon 12.7 multiplied by 100 upon 1.1, 6.013. So it means it's 6 carbons. 6 carbons, 6 carbon is present. I think it's again it's not working. Okay, now yes, 6 carbon. What is the molecular formula of the T? So T, uh, we all know that C6 we have already found it. H, okay, H is and it also consists O and B. Yes. So this is the 182 mg and it should be, if I put 4 here on phosphorus 15 and like something 15 here, H15 C6 H15, uh, yes it must be, yes. So 4, we already we have done with this. Okay students, I hope you like my video, you understand very well. Please like my video, subscribe my channel. So uh, thanks for watching. In the next video I will do question number 4 for you. Okay, thanks for watching. Allah Hafiz.